A dust cloud lifts, then settles into a shallow bowl of bare earth. The body that carved it rolls once more, rises, and leaves a rim of damp soil that will hold the next storm. Rain arrives, the basin darkens, gathers and steadies. Frogs find it at night. By spring, wildflowers ring the margin. Nothing here comes from a blade or bucket. It is the quiet draft of ecosystem engineers who work with weight, not tools. Call it Prairie architects. Why Hooves shape wetlands, signed in mud and time. The map looks accidental until the pattern repeats across a valley. Grasslands tolerate extremes: heat, blizzard, fire, and long thirst. The herds that cross them are built for distance and rhythm. They graze hard on new growth, move, then return after shoots rebound. Wallowing cools skin and scours parasites. Hooves churn crust, mix litter, and press seeds into contact with soil. Herds merge and split, guided by wind, forage, and memory of water. Predators test the edges, pushing the mass across ridges and drainages. Calves learn the circuit within weeks. Only after tracking these routes does the architect step into focus. American bison, 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 bodies like weather fronts, writing hydrology with posture and dust. Here is the paradox, stated exactly as the core mystery. Why do repeated grazing and wallowing increase heterogeneity and biodiversity rather than degrade prairies under moderate densities? Repetition should simplify. Teeth shorten swards, weight compacts ground, rolling scours plants. Yet, in many places, the opposite emerges. Grazed patches become lawns of tight, nutritious grass, while nearby stands shoot taller, sheltering forbs and nesting birds. Wallow depressions, often 2 to 10 meters, 6 to 33 feet across, collect runoff after single storms, becoming ephemeral ponds that last weeks or months depending on clay and rain. The edges trap silt and seeds, then flip to wildflower islands when the basin dries. Dung and urine create nutrient hotspots, measurable in nitrogen and phosphorus, their halos visible in greener rings. Hoof prints fill with water after small showers. Seedling clusters anchor there. Fire follows this mosaic. Fresh burns draw intense grazing, which prolongs short grass patches and shifts the next fire elsewhere. What looks like damage at the scale of a hoof print becomes texture at the scale of a watershed. The puzzle persists. Under moderate densities, why does disturbance produce refuge instead of collapse? One hypothesis starts with feedback between grazing and regrowth. Repeated clipping on rich soils turns select patches into lawns that photosynthesize fast and regrow tender, attracting grazers back. That cycle concentrates pressure, leaving nearby plants, often forbs and taller grasses, less eaten. Birds that need structure nest in the taller zones. Grazers feed in the lawns. Insects partition both. The trade-off is spatial. Push densities too high, or drought too long, and lawns spread into bare ground rather than bounce. Resilience depends on rest and rain. A second explanation focuses on microtopography and water. Wallowing compacts the bowl and seals it with fine particles, increasing residence time after storms. Infiltration slows at the center, but often increases around the rim, lifting soil moisture for meters beyond the depression. Amphibians and invertebrates flourish in wet weeks. When water shrinks, flowers and ground-nesting bees take the stage. Evidence suggests these basins operate as timeshare habitats that shuffle tenants through a season. Trade-offs are clear. In very sandy soils, basins drain too fast. In heavy clays, water lingers long enough to drown seedlings that would otherwise colonize. A third idea traces nutrients and seeds. Herds redistribute fertility as they travel, dropping concentrated pulses where they rest. Dung beetles bury some. Rain dissolves the rest. Microbes complete the work. Seeds arrive in fur and gut, some scarified, some ready to sprout, and land precisely where moisture and nutrients are briefly abundant. The result is a moving archipelago of hot spots. Scientists still debate magnitudes and thresholds, but the direction feels steady. Pattern arises from movement. The limit is predictability. In yours, when rain is untraceable or arrives all at once, the archipelago fragments or washes clean, and nobody knows why one valley rebounds while a neighbor stalls. Overlay fire, and the mosaic sharpens. Fresh burns lure immediate grazing, suppressing regrowth height and steering the next burn to older, taller fuel. This fire-grazing dance keeps flames patchy rather than pan-continental. It also aligns with adaptation in plants that evolved under bite and burn. Buds protected at the crown, growth points near soil, rapid rebound after rain. Viewed this way, the herds are ecosystem engineers, not because they build static structures, but because they choreograph processes. Prairie architects. Why Hooves shape. Wetlands becomes less a title and more a diagnosis of motion. What remains is a question disguised as a footprint. When drought tightens and creeks retreat to their bends, the last water may sit in a shallow bowl stamped months before. Tadpoles race a clock, shorebirds test the margin, a calf drinks a mirror of sky. Deeper into the dry, even that mirror goes dull, and the basin powders back to dust. Then a storm reloads the script. The pattern holds until it doesn't, and resilience becomes a moving target. How many hooves, how many burns, how many rests does it take to keep a plain diverse and alive? The answer walks away as the herd does, rewriting what we thought we knew with every pass.